So I want to talk today about creating some efficient shaping rules in a MikroTik. This is something that can be tricky to do, and it's very easy to do in an inefficient way that really uses up a lot of resources on your router and can start creating performance problems on your network. So I'm going to show you now one of the most efficient ways I found of doing it, and something that you should be able to implement pretty easily in your network. So there's a couple of pieces we have to look at here. We have our firewall rules that we need to apply, and these are all under the Mangle tab of my firewall config, which is under IP and then firewall. And then we have the queues themselves, which you would probably end up having a lot of queues in here. I only have a couple just for the purposes of this demonstration, but this should apply to having all kinds of different packages and shaping that you want to do just as well as it does to this simple test one I have. So the first thing to look at here is for every service plan we're going to have 4 firewall rules. We're going to have 2 connection marks, 2 packet marks. The reason we're doing it this way is that inspecting traffic is an expensive operation. We want to do as little expensive inspection as possible, and so it's a lot better to do our expensive inspection on a new connection when it's established rather than doing it on every single packet. And if we do that, then when we inspect the connection, if it matches our criteria, we can mark the connection, and we can then use that connection mark to mark our packets, which is a lot cheaper. And the reason we have to do both those things is in our queues, MikroTik requires that we use a packet mark in order to match here. So we need to get a packet mark on, but we don't want to inspect every single packet because that's going to start using up CPU pretty quickly. So if we take a look at the connection marks, I'll walk you through the settings here. They're pretty simple, I think, in general. First thing we're going to look at is the General tab. Here my chain is pre-routing. I would start by using the forward chain here. The reason I'm using pre-routing is I'm actually NATing on this interface, and so I'm using pre-routing because I need to look at my private IPs before they get NATed. But generally speaking, if you're applying all these rules to a customer-facing interface and the NAT is happening elsewhere or upstream, or you're not NATing at all, you can just use the forward chain here. Down below that I have my interface set to bridge local. So bridge local is the interface that my customers are connected to. So what we're setting up right now is the connection mark for upstream traffic. So if you think about this, if a customer is connected to bridge local, packets inbound to that interface will then be outbound from the router, which means they're going to go out to the internet. So when we set our in-interface to bridge local, which is our customer-facing interface, we're configuring the mark for outbound traffic, which is our upload speed. Under Advanced, I have the source address list set to me. We want to use the source address list here because these are packets coming into the interface, which means the IP we care about, the customer's IP, is going to be the source IP. And this address list called me is just a little address list I set up with only my IP in it for testing. But typically here you'd be picking one of your address lists that Sonar's writing that contains all of the customers that are in a particular package or whatever criteria you're using to shape. Under Action, the last thing we want to do here is mark the connection. My new connection mark I'm calling outbound, so I'm naming mine based on the directionality towards the internet. You could really name these whatever you want. You probably really want to name these based on your service plan, so you might call this something like Platinum Outbound or Platinum Upload or Gold Upload or whatever you want, but this is what I have here. So if we take a look at my other connection mark rule, it's very similar. I'm doing this one in post routing because of NAT, but again, you probably can use forward here. My outbound interface here is bridge local, so what this means is these are packets leaving bridge local, which means they're going towards the customer. So that means they're coming from the internet, so this would be my customer's download speed. Under Advanced, the destination address list now is me because, again, what we need to catch is that customer's IP, and if the packet's leaving the customer interface going towards the customers, then the customer's IP that's in this address list would be the destination. And my action is mark connection, and I'm calling this one inbound. Kind of same deal as before. My directionality here is in reference to the internet. So these are packets inbound from the internet. Again, you name these however you want. And bear in mind, you do need a unique connection and packet name for every queue that you want, so for every service plan that you have. So you will need to get a little bit more specific here than I have. So I have my 2 connection marks here, and my expensive operations here are looking in this address list to see if the IP address matches. So I've limited the expense here by only looking at my customer-facing interface. And we also want to do this not just to save resources, but because it makes it really clear the directionality that we care about. If we don't specify an interface here, one, we would look at every interface on the router, which is not cheap, and 2, you can run into problems with the queues getting applied in the wrong direction and that kind of thing. So make sure you do that. So we've set our interface, we've set our source address list, our expensive operation, we've limited it here, and then we're just marking the connection here. So once I have those 2 set up, I can go to my packet marks, and these are really simple. They're in the forward chain, and I just look, is there a connection mark on it? And if there is, I mark the packet. And for this outbound one, I've called it up. And here, same deal in my forward chain. I'm looking if there's a connection mark called inbound, and I've called that down. Now, maybe my names are a little confusing again. You use whatever makes sense to you. Just want to remember your directionality of these 2 connection marks. And we could also put a limit on these. I think this probably actually makes sense to do. So if it's outbound, if the connection mark's outbound, that means it's outbound to the internet. So that means my interface here would be bridge local. So let's set that. And here my out interface would be bridge local. And so, although this is a fairly inexpensive operation looking for those connection marks, I'm still going to limit this to my customer-facing interface. Again, I really want to reduce my resource consumption here. One other thing to note on higher-end MikroTiks where we have multi-core processors is in a lot of places in MikroTik, if we start to specify interfaces, it'll actually dedicate a core to some operation. So for example, when we do the queues in a minute, you'll see by specifying the interfaces, we can actually bind those queues to a specific core, and we can distribute those queues all across the cores. When we're not doing that interface specification, a lot of the time it'll run on one core, and this is where a lot of people run into performance issues. So again, just to recap these quickly, we have 2 connection marks. I'm looking at my in interface, I'm looking at my chain, I'm looking at the address list, and then I'm marking the connection, and I'm doing that again on this one for the other direction. Looking at my out interface, I'm looking at the destination, I'm marking my connection. And I'm just taking those connection marks here, looking at what the marks are, and applying a packet mark. So there's these 4 rules. You're going to have to make 4 for every service plan. If we jump over to queues, there's 2 things we have to set up here. We have to look at the queue types. So we need to make 2 queue types for every service plan. A downstream rate, our download, and an upstream rate for our upload. I've just called mine up and down. Again, you probably want to name these after your service plan, so platinum, gold, silver, whatever. So if we look at the down, we want our kind to be PCQ. The rate here is the rate of the queue, so I have this set to 50 megs. That means this will be a 50 meg queue. It'll allow people to move traffic at 50 megs a second. The limit here is the number of packets that can go into the queue, and so it's important that these are set correctly. If the limit's too high, what will happen is the MikroTik will queue up a lot of packets, and you're going to get a lot of latency, and it's also going to use a lot of resources on the router. If it's too low, then we're going to start dropping packets too early, and we're going to get a lot of packet loss. 50 is about what people seem to recommend. It's worked fine for me. I would certainly recommend experimenting with this a little bit and see what you think works the best for you, but this can be a tricky thing to really figure out. It's all sort of comes down to that customer experience, but 50 here I think is pretty good. The one you really want to pay attention to is this total limit. So the way PCQ works is that when we create a PCQ queue, we're defining all these criteria, but then every customer that matches the queue gets their own stream. So if we say our download rate's 50 megs and we match 1,000 customers into this queue, they all get 50 megs each. If you think about the limit here of 50, that means for each one of those queues we can buffer in there up to 50 packets before we start dropping them. And you want to drop packets. I mean, this is how TCP backs off and everything, so this is not a bad thing, but we're allowing the 50 packets per queue. The total limit is the total number of packets that can be buffered across all the queues. So really what you want this to be is not so big of a number that it could consume all of the memory on your router, but not too small that you have customers that are trying to get packets buffered and are not able to. So the normal recommendation here is this value is whatever your limit is multiplied by your number of customers. Now, if you're using a high-end MikroTik, you probably have plenty of memory and it doesn't really matter too much. You don't want to make this too small. Let's say you have 20,000 customers, you probably don't want this to be 20,000 times 50 because what happens as you grow, do you want to keep coming back in here and tweaking this? So I think setting this to something like 2 or 3 times the quantity of customers you have is probably fine, as long as you have a decent router. If you're using a very small MikroTik, this will become more of an issue, but something to bear in mind. We also have this option for a burst rate here that we can use in PCQ, and this isn't compulsory. If you don't want to allow bursting, you don't have to allow bursting, but the way this works is that bursting will occur if the average rate of the queue over the last number of seconds or minutes or whatever we have here in burst time is smaller than this burst threshold. If that's true, we'll allow the connection to run at this rate. So again, what that means is if the average rate of the queue, so let's say the customer's average download over this period of time is less than 25 megs, we're going to let them burst up to 75 megs. And then the inverse will disable bursting if the average rate over the last 10 seconds is greater than 25 megs. We'll stop bursting and drop it down to 50 megs. So if you want to allow bursting, think about what your config should be here. There's no right answer. I mean, this is whatever makes sense to you. The important thing here is that your burst threshold is always less than your rate. Otherwise, you're never going to have that scenario where it switches off, right? You're going to be bouncing either backwards and forwards between this rate and a burst continuously. Or if your threshold is greater than your burst, I mean, they would just burst forever, which kind of defeats the purpose. So normally the purpose of this is to allow short-lived connections to burst to a high rate. It's sort of less important with high-speed connections, like at 50 megs. Letting somebody burst to 75 for 10 seconds probably doesn't really matter. But if you're giving very low-speed connections, if you're on a very bandwidth-limited platform, then letting people burst for a little bit can really help do that initial download to load a big web page or something like that. If you don't want to burst, again, just kill all of this and nothing will happen. The last important thing here is that we pick the right classifier. So this is what MikroTik uses to decide how to split up these queues per user. So this is my download, right? So it's going out of my customer-facing interface towards the customer, which means the customer IP is the destination address. So I want to set my classifier to destination address. And then these address masks down here is how this gets split into individual queues. So because this is set to a /32, which is a single IPv4 address, that means that for every unique individual destination address, we'll get one 50 meg queue. If I made this something like a 24, then that would mean the IPs would get split into /24s, and then we get one queue for each individual /24, which is probably not what we want in most cases, so I'm going to set this to a 32. There's also an option here to do this for IPv6, so you'd have to take a look at what kind of size IPv6 subnets you're giving out if you're going to do that limiting here, but we're just going to focus on IPv4 for now. So if I take a look at my up queue here, very much the same. It's up. I've set it to 5 megs, and the only difference here is the classifier is the source address. Remember, upstream traffic coming from the customer into my customer interface. That means the customer IP is the source IP, so we want that. So I have those two set up. You're going to want to make 2 of these again for every service plan you have, and then we go over to queue tree, and this is where all the magic happens. So if we take a look here at my down queue, which I've just added by clicking the plus up there. Really simple. Down, the parent is going to be the interface that the traffic is leaving. So when we shape on a MikroTik, or really on most routers in general, the router can control packets that are leaving an interface, but it can't really control packets coming into an interface. It doesn't control what other people are sending to it. So the parent that we pick here, we want to be the interface that the traffic is leaving. So for my downstream traffic, it's leaving the bridge to go to the customer, so my parent is bridge local. My packet mark is down. If you remember back from the firewall here, the packet marks that I set up were up and down, pretty simple ones. So my packet mark is down. My queue type is down, which is that queue type that we created right over here. And we don't really need to mess with the priority or the bucket size or any of this other stuff. This is all we need to do. Same deal for up. My queue name here is up. My parent is my Ether1 gateway. That's my outbound interface to the internet. So this is where packets leave when they're going out to the internet. So that's what I picked here for my parent. My packet mark is up. My queue type is up. Now, one of the things you may run into here with the upstream traffic is that it is possible that it could leave through multiple interfaces. So there's a couple of ways that we can deal with that. You can set this to global, which means this will apply to every interface. I really would not recommend doing that. It really is not efficient. It causes a lot of resource issues on a lot of MikroTiks. And you are then really also applying this to that customer-facing interface, which we don't really want to mix that up. What we can do is just create another queue, and we can apply it to the other interface. So let's say this was part of a ring, and we had, say, Ether 2 and Ether 3 that we wanted to apply this to. We can create two queues here, and we can apply one to Ether 2 and Ether 3. Now, the one issue with that is then potentially you can have traffic go through both interfaces, right? If you're in a ring, it is possible that some packets go one direction, some packets go the other. Most cases, if you're using something like OSPF, this probably isn't going to be the case. They're probably going to always go one way or the other, but it's something to bear in mind. If it's really a concern, you can always dual the rate limiting right at the edge of the network, and so you have sort of dedicated in and outbound interfaces that used to do that shaping, but a bit of a conversation for another day. Just bear that in mind here. So that's really all the setup that we need. Now that we have the rules here, we have a queue type set up, and we have a queue tree set up. This is a very efficient way for us to be able to do rate limiting, and it's going to be automated all through the address lists and Sonar. And we do actually have a tool on our website. If you go to the sonar.software website, go into resources, we do have a MikroTik rule generator where you can go and plug in your service plan name, the interface you want to use, the speeds, and it'll actually give you a script that you can just come and paste into the terminal here by clicking on terminal. That'll build all of these for you. It's worth understanding how these all work so that you know what to come and tweak if you want to change anything. But if you're looking for a real quick way of doing this, go over to our site, go to resources, give that tool a try.